Does anybody want some bubblegum? No? Nobody for bubblegum? Okay, cool. There's bubblegum back here. I don't know. Bubblegum. No. We'll hand some out afterwards. This is a pretty open discussion, so treat it more like a workshop. If you have questions, ask questions. We'll probably talk through some stuff. I have about like 8 slides or maybe 10 slides, and then we'll get into, probably just general discussion around reputation topics. A lot of what we just talked about beforehand. Oh, sorry, by the way, I'm Al from Koii. Alex, actually, but at some point my PR team decided Al is SEO friendly because there's a lot of other Alex Morrises in the world, so now I'm Al. We run Koii Network, which is designed to be kind of a general compute platform. The original goal was to map the internet, and then we got into this idea and we started realizing it'd be very helpful if people could make money off their own computers. Ethereum doesn't really do that anymore. It used to be great when you had a GPU, and now you can't. So the big question that we started out with, which we'll zoom into reputation in a second, but I want to set the stage for why it's really important to talk about reputation. A lot of people already brought this up in the last discussion we were having. The whole knowledge thing is kind of messed up now with the internet. We used to have like public libraries that handled a lot of this curation of information. Academic institutions were supposed to do it for a while. The internet used to work in affiliate marketing, as an example. So a lot of the internet is lies, and it seems to be getting progressively worse, and the incentives are not well aligned. So the whole decentralization thing is a really good way to fix that. The other side of this is that we'd also like that to be a resilient system so that it doesn't get destroyed 20 years from now or have history rewritten after the fact. And I think reputation is a hugely important part of how we accomplish that without getting worried halfway through that the thing is a giant lie. And then presumably if that happens, then we lose our faith in the reputation information system, then people will replace it with something else that will probably be a bunch of lies. So there's a few challenges in the process of looking at this. The first thing that's gigantically relevant here is structuring unstructured data. So the internet is a gigantic mess of information, and the offline data that's been piped into the internet is not well cataloged and mostly not well verified. So there's a huge issue of just looking at all this information. In order to do that, we think probably the main way to do it is validating state models. So you need a lot of people who have strong reputation to take the information, verify it, and then put it into a system that everybody can trust. Of course, validating the input data of that system is equally problematic. So we started out trying to look at web scraping, and we gradually went down that rabbit hole, and now we've started to try to generalize that. Building stable and mission-critical systems is also a huge part of this. So just having something that works isn't actually good enough. We have to have something that people can use as the foundation of society or for their business needs. So there's a mix of staking-based systems and reputation that's required to make these things really stable. At the beginning of the talk, there was a little line under there, which people may or may not have read, which said that the reason reputation is so valuable is because it reduces the replication rate of your work. So if you have a certain number of compute cycles available to a network, you want to have most of those compute cycles go towards useful work, and then a very small number of them should go towards audits. That's enormously important if you're talking about building stable systems as well, because it means that if you have a higher rate of audits over time, it reduces the overall effectiveness of the network, and so a brief period of high audits can actually reduce the overall functionality of the system. And then finally, we want something that's going to be secured against history modification. We started out building on Arweave, so we're very happy to be here working with Filecoin now. We no longer believe that they are securing what they're doing against future manipulation, which is unfortunate. And they just made a deal with Meta, so I think they sold out. So Sybil resistance is also another major problem here. We want these systems to not be able to be faked out by people. So somebody who comes in should be able to make an account and be part of the system, but we also want them to, over time, build up that reputation without precluding the addition of new entrants, because we want this to continue for a very long time. So with all that in mind, stepping back for a moment, you guys have already probably all seen this, because you're pretty well spoken and know the space pretty well. Also, sorry, I made these slides very quickly, so I copy-pasted some stuff from old slides. The whole decentralization thing is actually the middle step, and we haven't actually really gotten to distributed systems yet. I think the key to getting there is probably mostly reputation as well. One of the main reasons that we have blockchains right now is because those validators that run those nodes are the most trustworthy people in the ecosystem, and we currently are basically paying them all taxes. So if you enter one of these ecosystems and you run a dApp, you are mostly paying taxes to validators of that network, because those are the people who are trustworthy to process transactions and order them. This is a gigantic problem, actually. So again, reputation, hugely important. Bitcoin, early version of this, right? People figured out we can put blocks in chains and we can trust the state of that network. Vitalik had this general idea that you could turn that into a state transition system, which is pretty cool. And a lot of people got Lambos. So this vision for a world computer that they had back in 2015, though, is actually a 3-part system, not a single-part system. So they built the Ethereum Go clone, so that was like the original node, and the Gavin Wood team in Berlin were supposed to be working on another version, and that didn't really get done. The other thing that was in the roadmap, though, was Swarm and Whisper, which were supposed to be these other 2 components of a world computer, which would be this decentralized knowledge engine. Swarm, if you're not familiar, basically was supposed to do what Filecoin did. Swarm still hasn't figured out incentive models. We'd love to see that continue. We like their team a lot, actually, and I was fairly close with one of the original kind of creators of the system. So that's what Swarm was. Whisper is the other side of this, which is communication layer nodes. I think we can actually generalize communication layer nodes to be more like compute nodes, which again, still need reputation. The reason this is really important is that Ethereum is very good as a blockchain at sequencing data and having a history of what occurred. And storage layers are very good at storing large volumes of data, but verifying that the large volumes of data that are stored in the storage layer, represented by a CID that is injected into a transaction layer, verifying that that CID that's in the transaction layer is correct, requires a massive volume of validators that are off-chain that can look at that storage layer and then put that data into the settlement layer. So this is just, again, scoping out the problem and trying to figure out what exactly we need to do here. This is a fun Reddit post from 2017. It basically seemed to have been kind of up and down. Swarm, again, is now being revitalized a little bit, but still moving very slowly. So what do we get in the meantime? We now have a lot of storage networks. There seem to be constantly competitors coming out in this space. We don't really have compute nodes, which is, I think, why we're all here. And then transaction sequencing and logic is now very widely adopted, and there's a lot of development happening there. Lots of people have figured out how to put lots of things in order and verify them. Very few people have figured out how to put data into those systems in a reliable fashion. So what we mostly see now is you get projects like LivePeer that are really heavily adopted, but they have their own communications nodes that are doing their own compute thing, and it's not generalized. And if we can fix the generalized compute thing in the near future, hopefully by getting a strong enough reputation framework that it becomes fairly trustworthy, then what we get actually is an acceleration of development on the other two parts of this system, the storage and transaction sequencing, which is really exciting because then that means we actually get closer to the objective of a world computer without getting completely sidelined on trying to build like 100 independent nodes that each need to be maintained that are not consistent and don't allow anybody to build on top of them, which would be very bad. Anyways, so that's a big list of those things. You guys have probably seen Juan's compute triangle. There's this kind of tricky thing right now where you've got three types of compute that you can do. So if you have fully deterministic machines like the EVM, they are very effective for small things and not very many wider things. There's languages that you can use to verify every line of compute, but those are inefficient because your replication factor is high. You have to replicate most of the data, or you have to have some way of verifying those proofs eventually, and you're verifying too much data. So what we do is something called tasks, which basically means that you have bespoke proofs for each task. And so when you create a task, you say, this is how I'd like to verify that somebody did it properly. This trends towards being greater efficiency, I think. That's what we're working on. The idea here is if you've read a web scraping tool and you want to verify web scraping data, that has a different kind of audit than something that does something else, like hosting a REST API. And generally speaking, the type of audit that you build into your task is going to determine how that works. The problem we ran up against is that you have within each task now a different way of verifying that the compute was done properly, which means that you have to adjust the reputation within each task. And so the big problem that we're seeing is that you need to then aggregate the task-specific reputation of each node operator within each task they're being asked to do against the criteria of that task into some kind of a larger reputation that can be used to select which nodes should be included in a task. And at the moment, the best that we've come up with for this is to say that each person who creates each task can say which people should be allowed into their task based on some arbitrary analysis of the network and what is available. And we'd like to get past that. So that's what our discussion will be about. The cool thing about this, though, is these bespoke proof frameworks are very good at fixing kind of wider problems, and they're very flexible. So as opposed to trying to have something that's very specifically in one direction, each task that you write can go wherever it needs to go. So if you need a high privacy task, you have one. High performance, you have one. High verifiability, again, you have one. Anyways, so audits, waste, network cycles. I said this before. Every audit replicates the same work. And go ahead.
What would be an example of a task with a task-specific proof?
Okay, so one example would be if you have a large data set and you want to create an index, that's a deterministic task where you can have a deterministic output. If you have a data set of data on a website and you're trying to scrape that, you need to do a probabilistic analysis of it and basically remove outliers. And the outliers get audited, whereas the people in the middle get a reward. If you wanted to do something like, what's another good one that we've had recently? REST APIs, another really good one. So if you want to do latency on a REST API, you need timestamps on the ingress and on the return. If you have those timestamps, then you can compare those timestamps. And in order for somebody to get a reward, they have to aggregate enough of those timestamps. We've also done this for DAG generation. So if you have a large DAG like our DIDs, you get the nodes to compete to add data to the DAG. And then the more of the Merkle tree that they submit, the more of the rewards that they get. And you can do proportional rewards based on how much of this data set they're maintaining personally. So there's a few examples, but I should say as well, what we're mostly trying to do is to create a framework that allows people to try a lot of these things. And then the goal is that as we have that framework, then lots more of these audit mechanisms will be discovered. We've also been digging very deep into management science because it turns out that they did a lot of this stuff to figure out how to get people to not take money out of cash registers. Yeah, there's like a huge amount of data that like McKinsey and company have done about this stuff. Very quick, good question, sorry. These audit cycles and reducing audit cycles is kind of the main thing. We think that over time, audits become less necessary if you have strong reputation for the specific reason that there are only two types of actors in the world. So you generally speaking have good people who are like 90% of the world, or 99% of the world. And then you have bad people who want to screw with things. This might sound ridiculous. I see some faces. So what I would say on this front is there's a reason that you can go get in an Uber and not get kidnapped. There's a reason that you can get into an Airbnb and not get stabbed or murdered by your host. The reason that that happens is because over time you sideline the bad actors, and most of the ones who are choosing to be good actors tend to continue being good actors over time. It's like one of the foundational principles of society. So reputation system allows you to sideline bad actors and keep lots of good actors. And the good actor over there has a nice little halo over her head, but you can't see that on this screen. That's too bad. We're trying to find all the good actors. That's generally the idea. So CARP is the thing that we are kind of in the process of incubating. This is meant to be an open protocol. The attention bit we'll come back to, but the general idea is compute and reputation is key. So you need reputation, compute, and some kind of an incentive, and we'll come back to the attention. So the way that CARP works, more or less, is that a party wants to do something, so they create a task by submitting some kind of a thing, usually an executable, along with some kind of a bounty that they fund into a pool. This is then observed by someone else, and someone else stakes tokens and reputation. The idea with the observer here is that they're watching that audit and executing an audit cycle if necessary. The goal is that they shouldn't have to execute that. At the end of the task, someone gets paid a bounty and a stake is returned to someone. The thing that we added, obviously, is a reputation pool. So the reputation pool gives you some kind of a feedback cycle on what's happening. These reputation pools are task specific though, so this leads to a larger problem, which is of course that when you create the task and the first person tries to run it, there is no reputation for them, and you then kind of have to trust that they're not going to lose their stake on purpose. So you want to get a larger, broader reputation pool and also a global task pool. One of the things that we've noticed is that if the global task pool actually assigns the task to the second party based on their hardware specs or other previous information about them, you can kind of add a little bit more of the structure to the reputation side. And so instead of just trusting that someone's going to self-elect to join the task, you can select a node that has opted to be available for certain types of tasks or certain types of hardware specs. And if you do that, you get a little bit of a boost in how much you can trust them because you're not as worried that they're going to misbehave. Does this mostly make sense? It's not actually that complicated. It just kind of helps to have diagrams. So strong reputation is everything, basically. If we can't get strong reputation systems, we can't trust people when they go to stake to join something like this. And if we can't keep those reputations strong over time, then we have to do a lot of duplicated cycles, and we get into a lot of really sad places. So to explain the attention thing really quick, can anybody in the room lend me €1? Anybody here? Okay, I got 2 hands, great, 3, 4. Okay, so I had your attention. We've created a bond of trust. That means I now have debt, which I can use to create currency. A debt is currency for the most part. So that's why we picked attention. It's a really good way to, yeah, see, I got €1. Amazing. I'll take that. Thank you. Lovely. So we picked attention because it's a really good way of bootstrapping. I will maybe give this back to you later. I'm not sure. You trusted me, so it's up to you. So the thing about attention that's neat is it's basically freely available, but it is socially derived. So it's somewhat Sybil resistant. And if you have a reputation heuristic attached to the attention that you send to somebody, then you're able to set sort of a value to their DID. So we do a thing where we do proofs of real traffic, where we can track the amount of attention that a piece of content receives. And this has allowed us to distribute about like 400,000 tokens in the Koii network. And along with that, we got 45,000 nodes RSVP'd who want to run these on their home computers. And so this is kind of a fun way to set up a reputation system. It's what we came up with. I'm sure there are lots of other ideas. So some general open questions that I would have for you guys are, how can we bootstrap reputation faster for a lot more of these networks? How do we get a lot of people to make an ID? How do we store this information? Where should we put it? Where do you guys want it? Because it'll probably make it a lot easier for you. We'd like to share most of it. And, wow, this is really not clicking for me. What data is useful? So if you're going to make an ID system like this, do you want it to be DIDs, attestations? Is network history the most important thing? And what are the best ways to accelerate this towards a stable equilibrium? Because once we have a stable group of good actors, then it becomes very hard for bad actors to join the network and subvert what's happening. And until we have a group of good actors that we know we can trust, we have a gigantic problem of trying to find those good actors, I think. But that's a very rough summary of what we're kind of thinking about. Yeah. Any thoughts? I think I understand what you're saying. So in our case, you have a personal reputation. And then when you delegate that to a node, that node has a reputation. And so if I spin up an AWS box and I run a node on it, that node has a derived reputation from me. If that AWS box gets hacked for some reason and seems to be misbehaving, I can revoke my permissions to it, and it can no longer act on behalf of my reputation. So if my machine misbehaves, I should be penalized. Yes, no, that's kind of how we're thinking about it. At the moment, the other thing I should say is we currently only have task-specific reputations. And so the goal is that people will choose how to let people join their tasks. So if you run a task that is doing a lot of stuff, you can issue attestations to people who do a good job. If those people consistently do a good job, they have lots of those attestations in our global DID system, and then somebody else who's running a task can choose to operate with those people because they know that they were a significant participant of a previous task that went well. But yeah, definitely agree. All the machines need to be completely tracked. Otherwise, we get AIs spinning up machines, and that's scary. When the AIs eat the internet, we'll all be very sad. Go ahead.
And then using that good reputation to target some specific individual or entity on the platform by turning bad.
Yeah, agreed.
Or revealing their badness later.
I
Are
think
there any
that
ways to mitigate that?
I think that's one of the main problems with the audit systems. So you generally have the issue that, let's imagine like a blockchain bridge. So I participate honestly on bridging two blockchains by, I check Ethereum and then I check, FVM or something. And I'm doing this job of ferrying information back and forth between these two chains. And then I'm waiting until the bridge contains $20 million. And when it gets to $20 million, I am willing to forsake my reputation to take the $20 million. Right. So I think in that case, the trick is not to prevent an individual actor from misbehaving. It's to have enough good actors in the system that are independent of each other from a social standpoint, that those independent good actors will be willing to continue operating, and it's very difficult for them to create a cartel of some kind. So I think the best way to do this is if you need 20 validators to bridge a transaction, then you need to have 10,000 to 50,000 validators available, and then kind of fisherman style just choose one each time that something's about to happen. And so then coalitions between them become harder to find because you're basically looking at a small subset of a very large pool that are supposedly all good actors. But yeah, I agree. I think that's generally the gigantic problem is using the reputation data, so there's a mix of the two things. Yeah. John?
What if, following your example of $20 million in a bridge, you make it so you split it up, so the most someone can walk away with, if they decide to go that route, is $20,000. And so it's prohibitively expensive to actually spend the time to build a reputation to steal only $20,000. So you basically secure the network through economic blocking.
Yeah, that's exactly what we're kind of thinking with this. I think the trick here is that we're trying to map an organic system, which is like human society. And so humans are not actually possible to map with an algorithm generally because we evolve fast enough. So the goal is that we have lots of symbiotic organisms called tasks that are each individually trying to accelerate towards being stable. And so, yeah, each task developer can add these kinds of incentives to try to make it a minimal risk of failure within their task, I think. But yeah, I totally agree. Hopefully the ideal outcome there too is the amount of tokens that they have to stake plus the reputation that they've earned to even join the task in the first place means that they have to contribute enough value to the network that they could have just spent the money to make that same amount of money elsewhere, which Levy gave a really good talk on yesterday. But yeah, one question just generally for the audience, I noticed a bunch of people who are all working on platforms of some kind. What is the best standard for IDs that you've seen that you want to work on? And actually, I'm going to come down from up here because I'm just standing up here on a stage now talking to you guys about what you think. But does anybody have any thoughts on where we should put this information? Yeah.
I had maybe an approach for the easier problem, which is number one right there, which is, well, maybe we can use some kind of deposit and slashing mechanism to bootstrap reputation. Filecoin does something really similar, right? So rather than, because I think the idea is, correct me if I'm wrong, this idea is in the beginning you want to audit pretty often just to make sure that this person is trustworthy, and eventually you're going to start trusting them, right? That extra replication in the beginning could be replaced with a deposit on the part of the people who want trust. And if they misbehave, because again, you do want to periodically audit even people that you trust, right, to avoid the problem that we were discussing earlier, that might be a way to bootstrap the reputation faster than just replicating a lot in the beginning.
So do a lot of audits at the beginning of each task, and then you've gradually created a group of good actors? Sorry.
Well, so I would say, so that's one approach, but that seems to me to be the slower way. So the question is, how can we bootstrap reputation faster? So that's like, I would say that is the default way, right? In the beginning, you do a lot of audits. The alternative is the person who wants to be trusted more is willing to put up collateral that can be slashed if they are found to be malicious at some point. And you do want to do periodic audits, even on nodes that you trust, because those nodes could just be faulty. There could be something wrong with the hardware or something else, the operating system, and that could be causing major problems as well.
Got it. There's one cool mechanism that I saw for this. Someone suggested having your voting power inside of a task or your reputation in the task scaled to the amount of time that you're willing to stake for. So if the task cycle is 1 day to accomplish some task, like I want to scrape some website once a day, then I get people to stake for 1 day as the base, and they only get their tokens back when they're not audited. Or they can choose to stake for many days. And if they choose to stake for 8 months, we know that they can't get their tokens back, so they're going to behave honestly for that entire 8-month period. And you can also lock up all of their rewards into that same pool until the end of their staking period. And so if you do it that way, you can scale up their voting power significantly, because if at any point in the first 10 days they're audited, they lose everything. They lose all the rewards, and they lose 8 months of stake, which works very nicely to offset these kinds of risks. But it's, yeah, acceleration point for sure.
I'm curious why you want to bootstrap quickly.
Because the world's going to end with nukes and robots.
But it risks the security of the system. So like when you build a system that is going to be foundational to a lot of stuff, it's better to start with an emailing list and then grow it to a small forum somewhere and then get it out there and beg people not to adopt it as currency for their whistleblowing website, but then they do anyway, et cetera. So like it sometimes benefits the system to go slowly and really, really make sure that foundational layer is very trustworthy, so that when bad actors do try to come in on the more open beta, so to speak, then you have those very trustworthy people to kick out the bad actors.
Totally agree.
But I understand the rush to stop nukes.
I think the general problem that I see is that like most of the political process in the world is controlled by information websites, which at this point are mostly quickly becoming somewhat authoritarian in how they think about things. And so that's the problem we set out to fix, which I think that problem's accelerating in its value to society. And so finding enough of these validators in the next like 5 years feels like a critical survival thing for our species.
But if it's based on something like stake, won't those people just buy the coins, stake them up, and they're all of a sudden the very trustworthy people that are bootstrapping the network, and then you're just giving them a more resilient infrastructure to operate on?
Definitely true.
So how do you keep those?
We have a problem with
people
them all killing us.
Yeah. So how do you keep the people that we're trying to stay away from that foundational layer so we can build it in a commons infrastructure? How do you keep those corporations out from this foundational layer if you're injecting money, as money equals essentially trust?
Yeah, because then it's just proof of stake, and we have that problem again. Yeah,
Yeah.
I get it. I think the idea is that each individual task can build up its own reputation group within the task, and then the value of those task-based reputations have some global significance on a broader scale, depending on how the global structure chooses to interpret them. And so you can get people to stake a lot in the short term to run each task. Like if you wanted to run a web scraping bot and you wanted to find a group of people that are going to do that, and you want to do that tomorrow and you needed 50,000 of them, you can get them to stake tokens because you can't trust them yet. And then that is one example then of their commitment to building things like this. And then if there's, if that particular node operator has, a bunch of other stuff that they're also doing over time, and they're staking a lot of tokens, providing a lot of services reliably, there's no reason to slow it down, I guess, is my thought. But I totally agree with you. We don't want to rush it.
No, and I think
quickly.
Yeah, like some sort of weighted mechanism where it's non-monetary contribution combined with some sort of monetary contribution, and that's dynamic and can evolve. That would be pretty interesting.
The other way to do it would be, I think what you said the other day, which is getting them to do stuff for free, which is kind of fun.
Yeah.
It's like if you help us with scientific research for the next year and a half and contribute a bunch of computers, then maybe we give you a boost in reputation for that, like the global side.
Exactly, yeah.
That would probably work really well, actually. Because then they're really not getting any more collateral, and they actually have to continue putting their own money in. But
if they want to get rich, they got to do science.
That sounds like a good idea. Yeah, I will now cede the mic, and if there's no more kind of thoughts on this, we can just kind of go back to sitting around talking about stuff.
If you don't mind, I would love if Brooklyn actually had a second. They're doing some really cool stuff on IDs and stuff. It's the woman back there right behind you. Could you just hand her the mic?
Hi. So I just got here. Sorry, I don't have all of the context. My understanding is that the question is about which IDs we should use, and specifically which DIDs. Is that roughly correct?
For tracking reputation across different task environments on different networks, ideally. But yeah.
Specifically for reputation.
Specifically for, tracking like global reputation so we know which computers are trustworthy people to run things that we ask them to do.
Right. So is the question more about the reputation system or about the IDs?
Well, the broader context is the reputation system that we're doing it in, but we'll need identifiers for humans, for machines, for system accounts, for tasks, for organizations, et cetera, which to me feels very much like solidly in DID world. Is that? Yeah. So
Okay.
I didn't know if you had any thoughts on that.
So I can share a little bit about what we've learned running this kind of thing without, not the reputation part, but just making systems interoperable with UCAN and DIDs, is that it doesn't really matter. All that matters is that you can have some between two systems that are talking that they can actually resolve the thing. So we use DID key for basically everything because it doesn't need to resolve into a separate system at all. But if you have, you're on a HIPAA compliant service that needs to be able to revoke things instantly and all of these other things, then they're going to have some really specific system. I don't think that it makes sense to limit it to a certain specific DID because you want this to end up in as many systems as possible. And if somebody chooses to use their, some homegrown wacky DID that's not on any registry and that nobody else knows how to plug into, they will not be interoperable with the rest of the system, but that's what decentralization is about, right? You can choose to be in or out of the system, and it shouldn't need to know how to look up every possible DID around. You should be able to arbitrarily extend it, even if that means that you won't be able to interoperate with absolutely everybody else on the network, right? But everybody else should probably just use DID key, chances are.
Have you seen systems in particular? Like one thing we were talking about is the mechanism by which DIDs inherit from other DIDs of some kind, right? Reputation, credentials, whatever it is. I would guess that that's built into the system. I truly don't know. Or are you using that already?
So we're not. That sounds a lot more like verifiable credentials than DIDs.
Okay.
So this is VCs, verifiable credentials, allow you to attach information about a particular agent, and that might have one or more keys.
Got it.
As opposed to, like the intuition pump for this is, if you have a driver's license, you shouldn't be able to delegate that to somebody else, right? Who's not you.
Yeah.
So you manage the DID and say, here's a list of keys that are me, and that the verifiable credential is attached to that DID,
Got it.
and I can sign with any of these. That's really terrible UX for, I want to invoke this function on another system, right? Where you want capabilities. So there's slightly different, it's information about me versus what I can do.
Okay.
Yeah.
That's great. Have you looked at verifiable credentials at all?
Yeah,
How do you think it fits in?
So what we did was we made a DAG that has kind of a combination of both these things, and then you can hit any of the nodes that are maintaining the DAG on a REST API and get a list of their credentials that are verified, which the nodes have to say honestly or they get audited. But yeah, it's basically the same idea. You track a bunch of signing keys. We ran into this problem because one of the things we were looking at was bridging, and so you have to have a bunch of different signing keys for people. And so we just started clumping them all together and then giving them different privileges. It's definitely still this is very early on our side as well, so we're just trying to figure out what standards should look like and what we should do.
So it's interesting. Can I ask, did you implement, I'm not saying, I wasn't saying you were doing it competitively, but did you implement a new standard for verifiable credentials, or did you implement a system that picked up verifiable credentials and basically provided an API over the top of it, or something of that kind?
We didn't implement a new standard for it, but I was involved in Uport at one point about 5 years ago. So I've been looking at this stuff for a while and just kind of we just followed a lot of the stuff that people were always doing.
Okay.
The main thing though is I think a lot of these handshakes for I will delegate this to you, that kind of stuff needs to be globally identified. Otherwise, whatever reputation system we create at the top won't be compatible with all the things that we're all trying to build where we want to check that system. Which is, ours is hopefully going to be released in our faucet in the next couple days. And then hopefully that whole REST API thing that we made should be fairly well documented. I think the docs look really bad right now, though, so hopefully we'll make that look cleaner by the end of the week, and then maybe next week we can send it around. But yeah, that's kind of, it's still very much in beta. We started working on the DID DAG thing in August, so it just got to the point where it's going to be able to launch.
That's awesome. Thank you.
Yeah, more stuff to come. Thanks for your attention, folks.